I chose a couple of problems from Lesson 6.3 homework assignment that I thought I would try to help you with. And so here's number 22, this word problem. This bacteria grows at a rate of 3 cells for every 2 minutes. If we started out at 260 cells, how many will there be after 21 minutes? So this is a review of the formula that we looked at earlier in this lesson, where we can find a particular term, we call that nth term, using the first term times the ratio, common ratio, raised to the n minus 1 power. Okay, it's just how are we going to fill in, what are the numbers that fill in to this particular formula. Okay, well, the first term is probably pretty obvious. We had 260 cells initially, so probably got that one pretty easily. How would we represent 3 cells every 2 minutes? So you could think of that as the fraction 3 over 2, 1.5 cells, 3 cells every 2 minutes. So you could say R is 3 halves, 3 over 2. All right, and so what's N? So this is in terms of minutes. Remember, in our exponential growth, this exponent is typically an amount of time that has passed. Well, it's similar to what we've done in previous lessons, but it's like we're looking for, in this case, the 21st term. Okay, so it's like we're going to look for the a sub 21, which means that the exponent for 3 halves is actually going to be 20. It's n minus 1. All right, so now that you've got all the numbers identified, all the letters of this formula identified with the appropriate numbers, you can turn it over to your calculator, and you can do 260, left parentheses, 3 divided by 2, and we're going to raise that to the 20th power, and we get 864,566.7498, but we should round to the nearest 1 since we're talking about a certain number of bacteria. So let's just round that off to the nearest whole. So the answer would be 864,567. Okay, rounded. And since it's rounded, I guess it would be appropriate to say approximately. 864,567. All right, so that's your answer for number 22. So when you see problems like this in the future, hopefully having this problem, as I always say, make sure you can do it without looking at anything. Make sure you have understanding. And then here's number 52. I didn't really do one exactly like this in your notes, so I thought I would help you out with this one. It is going to use the formula that I gave you to find the sum of a geometric series. So let me just repeat that formula for you. You can find the sum of any number of terms in a series by taking the first term, multiply by 1 minus r to the n, and then divide by 1 minus r. Well, a lot of this is given. We know that S sub n is negative 10,922. What we're trying to find, according to this, is a sub 1. Okay, we know that r is 4. We know that n is 7. So down here we can say 1 minus 4. All right, so now it's just really algebra trying to solve for this variable. So this is good practice in trying to find the variable, solve for a variable in a fairly complex equation. All right, so let's just take this one step at a time, and we can take care of this numerator. So let's grab our calculator, and we're going to do 1 minus 4 raised to the 7th power, and that's negative 16,383. Let me make these a little bit bigger. Negative 16,383 divided by negative 3. Okay, so since these are factors, you can do the canceling here. Remember, you can cancel factors, but you can't cancel terms. So let's see, if we divide negative 16,383 by negative 3, we get 5461. So my equation now looks like this. I really haven't done anything to the left side yet, But dividing this, I get positive 5461 times a sub 1. And now it looks like it's pretty easy to solve for a sub 1 by division. 5461 on both sides. 61. And we'll grab our calculator one more time. Negative 10,922 divided by 5461. And we get negative 2. So our answer for a sub 1, the first term, is negative 2. All right, and so that should wrap it up. Hopefully the notes should help you with all the other problems. Make sure you consult with your notes. I try to give you some really good examples, but these two probably didn't fit within the scope of the notes I gave you exactly. You do have this formula, but I wanted to show you how you could use it to find other missing parts. So hopefully this helps you. If you have any questions, let me know.